Hello and welcome to the third session. In this session, we'll talk about the trusted environment of the OpenDID platform. This is one of the most fundamental lectures for understanding OmniOne OpenDID. If you follow along slowly, you'll be able to understand the core components easily. So let's get started. Let's begin by introducing the concept of the trust framework. In the OpenDID system, the trust framework is the structure that establishes mutual trust among participants. This framework is designed based on the principles of zero trust, meaning trust is not assumed but built through verification. It's essentially the process of forming a trust chain between entities and participants in the system. Initially, key entities are registered at the foundation of this trust chain, and from there, the chain continues to expand. This forms the foundation for all trusted interactions within the ecosystem. There are three main characteristics of this trust framework. First, it's a decentralized model anchored by what we call a trust anchor. This anchor serves as the starting point of the chain, and trust propagates from it. Through this structure, we can maintain a distributed yet trustworthy environment. And to distribute trust among participants and enhance transparency, the system aims for a decentralized structure. Second, mutual verification is possible among all participants. Anyone can refer to the DID document of another party and verify its authenticity in real time. And third, the system provides tamper resistance and auditability. Because the trust framework is built on a blockchain foundation, all records are immutable and transparently traceable, preventing data forgery and enabling accountability. Now, let's take a closer look at the internal components of the trust framework architecture one by one. First, at the very beginning of the trust framework stands the TAS. You can think of the TAS as the foundational root of the trust framework. It's where trust originates. However, in real-world operations, there's actually a separate committee that plays an important role. This committee first forms the initial trust repository through consensus, and then delegates authority to the TAS. So in essence, the true source of trust for the TAS comes from the committee itself. Keep this point in mind as a helpful reference. With the authority it receives, the TAS functions as a trust anchor. From that point on, it becomes the root of trust for the entire system. Entities like issuers and verifiers submit registration requests for their DID documents to the TAS. Then, the TAS, acting as the trust anchor, registers these DIDs into the trust repository. After registration, the TAS may issue things like certificate VC as a way to certify trust. Through this entire process, entities are included in the trust framework. And any associated apps, like the certified app or wallet, naturally become part of the trusted environment as well. Let's quickly summarize the key points we just covered. The trust repository, which is established with the consensus of the initial committee, is built on a distributed ledger-like blockchain, providing strong security and integrity. The TAS is granted authority by both the committee and the trust repository. It acts as a central trust anchor, responsible for managing and vouching for trusted entities. Once authorized, the TAS registers the DID documents of entities into the trust repository, and can issue certificate VC to certify trust. Through this process of entity registration and verification, all members of the ecosystem become part of a trusted environment. This trust framework is designed based on the principle of zero trust, where trust is never assumed, but earned and verified. And to ensure this, it uses secure protocols like digital signatures and encryption. In this way, the OpenDID trust framework forms the foundation for a verifiable, tamper-proof digital trust ecosystem where every participant can be securely validated. Next, we'll look at the process of establishing the trusted environment. In the OpenDID platform, the process includes TAS registration and entity registration. The TAS registration is the initial step where TAS is officially registered as the trust anchor. Entity registration involves subsequent registrations of issuers, verifiers, and others through TAS. Let's walk through each of these steps in detail. Now, let's go into more detail about the registration process. First is the registration of the TAS. The process begins with the creation of a DID document for the TAS. After that, the TAS submits a registration request. But here's something to keep in mind. In a real-world environment, the TAS cannot approve its own registration. Instead, this request must be approved by a committee. That's because, in this system, all trust originates from the committee. Once the committee approves the registration, the TAS officially becomes the root of trust and starts functioning as the trust anchor. Next, the TAS issues a certificate VC for itself. This credential is self-signed, which is acceptable in this case because the TAS is already recognized as a trusted anchor. Its status as the source of trust justifies this self-signed credential. And with that, the TAS registration is complete. Now, let's talk about entity registration. Just like with the TAS, the process starts with each entity like an issuer or verifier generating its own DID document. Then, the entity submits a registration request. This time, the request is sent to the TAS. You might wonder, how can we trust this request? After all, not just anyone should be approved. In this process, we assume that the request has been received through a secure and trusted channel. Once the request is validated, the TAS issues a certificate VC for that entity. And that completes the entity registration process. Let me review the procedure once more for clarity. First, it's about the TAS registration. TAS creates a DID document and submits a registration request. If necessary, this request goes through committee approval. Then, the registration request for the DID document is sent to the blockchain. Finally, the DID document for TAS is successfully registered. Along with this, a membership certificate is also issued. Now for entity registration. Each entity generates its DID document and requests registration from TAS. TAS then submits the request to the blockchain. Once the document is registered, TAS issues a certificate VC for the entity. This concludes our overview of the trusted environment. Lastly, let's briefly explain OpenDID's security components. OpenDID includes strong security features. First, secure communication channels are built using ECDH. This enables wallets and servers to securely exchange secret keys across endpoints. ECDH combines the Diffie-Hellman algorithm with elliptic curve cryptography to prevent eavesdropping and ensure secure communication. Next, end-to-end encryption is provided through AES-256. The secret key exchanged via ECDH is used to apply AES-256 encryption for strong, symmetric encryption during communication. Sensitive information like personal data and credentials can be encrypted within the communication channel using this method. Finally, digital signatures help prevent tampering. OpenDID uses the SECP256R1 elliptic curve algorithm to generate signatures. This allows verification of message integrity and authenticity, ensuring that received data has not been altered. And that wraps up our third session. I hope this session helped you better understand the components of the OpenDID Trust Framework. In the next session, we'll walk through the user registration process within the OpenDID system. Thanks for staying with me. I'll see you again next time.